Now, our second type of chi-square test is the test of association, also referred to as test of independence. Now, the test statistic looks very similar. Just as a reminder, the chi-square test of independence is bivariate, so it has two variables, which is why we have two different subs down here. We have an I and a J, so we'll walk through those. Similarly to our chi-square goodness of fit, we also have an E, but this time it's an E hat. So we are going to have to calculate that before we can move forward. So we have some new symbols in this particular test statistic. We have an Fij, we have an E hat. Now to calculate our E hat, our expected frequency, we have R sub I and we have C sub J. So those are new as well. So our R sub I is the 8th row total and our C sub J is the jth column total. Combined, we have the observed frequency for that ith row and that jth column. And we'll look at an example in a moment. But to get our E hat, our expected frequency, we take our row times our column and we divide that by our N. Now, similar to the goodness of fit test, our chi-square in this particular scenario is if our chi-square test statistic is greater than our chi-square point, we're going to reject our null hypothesis. So the test of association or test of independence is utilized typically with a contingency table, similar to what we see here. Now, in this scenario, I'm using B for bonds, S for stock, and T for tax deferred. We have high, medium, and low bonds. You'll see the very end we have our totals that add up all three, our high, medium, and low bonds, our high, medium, and low stocks, and tax deferred. And the very bottom, we have our totals of our highs, mediums, and lows. So we have a total of 100 of everything put together. So I've drawn another box up here that's the same size as our contingency box down here. This is going to represent my E hat sub ij. So our headers are going to still be the same as this, but just to save on space, because we're running out of space, I just wanted to get the meat of it here. So we're going to have our high be the first one, medium be the second one, low be the third one, and then same thing, bond, stock, and tax deferred down here. Our totals are also going to be the same, so we don't have to worry about that. But how do we calculate our E hat for each of these? So for this 15 right here, our E hat sub ij is going to be our row, which is 30, times our column, which is 40, divided by our n. So 30 times 40 divided by our total of 100 is going to give us 12. We're going to repeat that for each of these. So our E hat for 12 here for the bond medium is going to be 30 times 40 divided by 100, which is going to give us the same 12. And we're going to do the same thing for the low, which is 30 times 20 divided by 100, which is going to give us 6. We're going to repeat for all of those. So 24 is going to be 30 times 40 divided by 100, which will be 12. Ditto for the 4, 30 times 40 divided by 100, also 12. For the 2, it's going to be 30 times 20 divided by 100 is going to be 6. And our final row for our tax deferred high is going to be 40 times 40 divided by 100, which is going to give us 16. Medium tax deferred 24 is going to be 40 times 40 divided by 100, which is going to give us 16. And then last but not least, our 15, our tax deferred low is going to be 40, which is our row times our column of 20 divided by 100, and that is going to give us 8. Now, if we add all these up, we should get the same total. 12 plus 12 plus 6 is going to be 30. 12 plus 12 plus 6 is going to be 30, and it's going to match that. So this is a nice double check to make sure we have everything in order. 16 plus 16 plus 8 is going to be 40, and we can do the same thing on the bottom. 6 plus 6 plus 8 is going to be 20. 12 plus 12 plus 16 is going to be 40. 12 plus 12 plus 16 is going to be 40. And we're just going to double check and make sure our totals are the same. So we're in good shape. Now, after we've gotten our E hat, we have our frequencies, we have our E hat, we have everything we need for our formula. We just plug in numbers. Now, this is going to be much longer than the last example because we have a lot more numbers that we're dealing with. So I'll get us started and then we can wrap it up. So f sub ij for our first one is going to be, our chi-square is going to be 15 minus 12 squared divided by our E hat sub ij, which is 12. We're going to add that for the next one, which is going to be 12 minus 12 squared divided by our 12. Repeat for our low bond, which will be 3 minus 6 squared divided by 6. And then we're going to repeat on the next row. So we're going to have 24 minus 12 squared divided by 12 plus 4 minus 12 squared divided by 12. Then we're going to have 2 minus 6 squared divided by 6. I'm going to repeat it for the bottom row as well. 1 minus 16 squared over 16 plus 24 minus 16 squared over 16. I guess I'll work out all of this. And then we have 15 minus, 8 squared over 8. We calculate all of those, we do our squares, we do our minuses, we do our division, and we should come out with 46.4375. So this is our chi-square for this word problem, for this particular scenario. Our chi-square for this problem is 46.4375. And we know that if our chi-square is greater than our chi-square point, we reject our null hypothesis, just like the goodness of fit and just like any test statistic. If our test statistic is greater than our alpha, we reject our null hypothesis. Same is true for chi-square. If our chi-square test statistic is greater than our chi-square point, and as a reminder, we get our chi-square point from the table, from the chi-square point table. Now, to get our chi-square point from the table, if you recall, we have to figure out what our significance level is, and we also want to determine what our degrees of freedom are. Now, our degrees of freedom, this is bivariate. We have two different variables. In the goodness of fit, we only have one, so it's degrees of freedom minus 1. But this time we have 2. So what we need to do for our degrees of freedom is we're going to take our r minus 1 times our column minus 1. Oops. So in this particular case, we have 3 rows, 1, 2, 3. So we're going to do 3 minus 1. And then our columns are also 3. So we're going to do 3 minus 1 there. So 2 times 2 in our degrees of freedom is going to be 4. So on our chi-square table, we're going to look up degrees of freedom 4, and our significance of, in this particular scenario, we can use 0.05. So on the chi-square point table, a degrees of freedom of 4 and a significance level of 0.05, our chi-square point is going to equal 9.487. So this particular scenario, our chi-square of 46.4375 is greater than our chi-square point, so we're going to reject the null hypothesis.